So welcome to our class on probability distributions. Now I must make mention to say this is one topic that at this moment I must emphasize that you must grip with your mind, because this is one topic that many people fail to want to understand because probability is wide and confusing. And so since we are starting early, let us get to understand the probability distributions. I'll start with one of the easiest distributions, which we call the random variable. Now, when we're dealing with random variables, we're dealing with outcomes that take numerical values as a result of an experiment. So each time we're dealing with random variables, there are two types of random variables that you need to take note of. There's what we call the continuous random variable, and there's what we call the discrete random variable. In our first session, we were discussing the types of data that we have. So we talked about continuous data, and we also talked about discrete data. So even with probability, when we're dealing with random variables, is a continuous random variables, which is measured on a continuous scale. When we're dealing with measures like weight, measures like time, these ones are in a continuum. And so when we're dealing with precise measurements, for instance, exact value of weight, it's 5.2 kgs. So that is a continuous variable. But where we are dealing with outcomes that look at countable values, for instance, the number of children, number of scores, the number of strokes, these ones are countable values. You don't have decimals, in short. For discrete values, we are looking at whole numbers, integer numbers. Whereas when you're dealing with continuous variables, we're dealing with fractions and decimals. Now, this is a very easy topic. So for us to calculate the mean, the variance, and the standard deviation, we'll look at this example here. Now, this is an example from this textbook, 0.1 to 0.15. You will discover that these are the same figures that he used here. He just got it from there. So I'll use my own example so that you try this on your own. So if you're given values of x, which are discrete random variables like 1, 2, 3, 4, these ones are countable numbers. If we had a fraction like half, 2/3, this will be a continuous random variable. Then we are given the probabilities, which must, of course, add up to 1, like 0.3, 0.1, 0.2, and 0.4. You're being asked to calculate the mean, the variance, and the standard deviation. So the mean is actually the expected value, which would be summation of what? Not summation of x, it's expected value E of x. When you're asked to find the variance, symbol is the variance V of x. When you're asked standard deviation, it is simply this symbol, sigma x. Now, if I'm going to transpose this data that I have in here, 1, 2, 3, and 4, and we'll have my probabilities here, 0.3, 0.1, 0.2, and 0.4. So to find my expected value, or E of X, what I need to do is simply multiply these two. So the column X times the probability of X. As simple as that. So 1 times 0.3, we get 0.3. 2 times 0.1, we get 0.2. 3 times 0.2, we get 0.6. And 4 times 0.4, we get 1.6. Are we following? If I'm
Yes, sir.
ahead of you, you just tell me to slow down. So this
We
is
are following.
summation of XPX. So if we total up this column, we're going to get 5, 11, 17, 7, carry 1. So 2.7. So this is what we call our mean. So our expected value, or the mean, is 2.7. Then we're going to bring down the X, and we're going to square it. X, we're going to square it here. We're going to have 1, 4, 9, and 16. You can bring back the probabilities back here. So the probability is just the same column, 0.3, 0.1, 0.2, and 0.4. So what we're doing here is simply to multiply the X squared times probability. This is helping us come up with our variance. So 1 times 0.3, do 0.3. 4 times 0.1, do 0.4. 9 times 0.2, do 1.8. And finally, 16 times 0.4. So this is 24, 32. Then here we have 6.4. So we're going to add this column here. So this column here, we're going to have 7 plus 8, 15 plus 4, 19. So this becomes 8.9. So this total here minus the square of that total there is what we call our variance. So remember, our mean or expected value, we said it is simply summation of what? XPX, that column, which we found as 2.7. Our variance, therefore, is summation of what? X squared px minus the mean, the power 2, which is summation of x px. So in short, it is this column that we've just found here, 8.9 minus 1 squared 2.7. Kindly assist me. 8.9 minus 2.7, what do we get? 2.7 squared.
6.2.
So 6.2. So when you subtract 8.9 minus 6.2, what do we get?
2.7.
2.7. Okay. 2.7 squared, I show at 6.2.
Oh, it's squared. Oh, okay. Sorry. Let me redo it.
$1.61 as the answer.
As the answer, what do we get? 1 point?
1.61.
Okay. So this is called the variance. So meaning the standard deviation becomes what? The square root of the variance.
1.2688.
When you square root this variance, we get 1 point what?
268857.
Okay. All right. So this is how we find our mean, our variance, and our standard deviation. So whenever it comes in an exam, which it always comes, and in the test, don't get confused. So let's look at this question here. It came in the example, it has come 3 times, in fact 4 times in tests. So here you're given this question here. You're asked to find the mean. Can you remember how to find the mean?
The mean is just a summation.
The summation of what?
Summation of X.
This total here. Sure, you missed the first part. You multiply these two. X times the probability of X. This times that, you put the figure there. This times that, you put the figure there. This times that, you put the figure. The total is the mean. So it is simply given by summation of X px. So 1 times 0.12, 2 times 0.15, 3 times 0.18, 4 times 0.15, 5 times 0.26, and 6 times 0.14. So when you compute that, you get 3.7. This is what we call the average. Is that clear?
Yes.
Then how do we find the variance? We square the values of X. 1 squared, 1, 4, 9, 16, 25, and 36. Then you multiply this by that, this by that, this by that, this by that. The total is not the variance, but when you subtract the mean squared. So to find the variance, we use 2 methods. What I've told you is the easier method, which will finally give you 2.59 as your variance. Or alternatively, since we found the mean, we're going to subtract the mean from each value of X there. So 1 minus 3.7, we get negative 2.7. Then we square it. After squaring it, we multiply by the probability 0.12. Then 2 we subtract the mean 3.7, then we square it. After I square it, we subtract this figure from the value of X, we get that figure. Then again, 3 we subtract 3.7. Mind you, all negatives become positive when we square them. When we get the figure outside. And until we reach the final answer, 6 minus 3.7, we get negative, we get 2.3. 2.3 times 2.3 squared, we get this one, 5.29. 5.29, we subtract it from the value of X, we get 0.7906. The total is what we call our variance. So variance, when we square root it, we call it the standard deviation. So this is what came last year in the form of this table here. The exact question in this example, you're being asked to find the mean, the variance, and standard deviation. So these are 6 marks. So I don't want you to lose any marks at any point. So whatsoever says well for you, go for it. Okay. Whatever says well for you, go for it. So this question is expected to come through your first test 1. So just mind, because he doesn't want to make people panic. exam questions repeat themselves in the test. So there was a very good performance in the exam, in the test, but not in the exam. So this disparity, we need to kill it by you understanding and not memorizing. Is there anyone left at this point? Are we together? So this is how we get the 6 marks there. So the mean, multiply this by that, this we get this by that, this we get this by that. The total here is 3.7. Find the variance, subtract this from there, square it, times this, we get the figure. This minus that, square it, multiply by this, the total is your variance. Or the easier one I gave you in this particular instance example. When you multiply this by that, you get this by that, we get this by that, we get this by that, we get this. So directly what you get is your mean. And bring back this column, you square it. 1 squared, 2 squared, 4, 3 squared, 9, 4 squared, 16. Then you bring back this probability here, 0.3, 0.1. Then just multiply this by that, we get this figure. This by that, we get this figure. This by that, we get this figure. The total is 8.9. This is not the variance. But when you subtract 8.9 minus 2.7 squared, that is called the variance. So 8.9 minus 2.7 squared, you get 1.61. Then when you square root this, it's called the standard deviation. Anyone behind at that point?
We can move on.
And move. Okay. So we're going to look at another probability distribution, which is very important. And this is called contingency tables. Contingency tables come often in form of a tabular form. So now, this afternoon, we discussed basic principles in probability to say, number one, the probability of an event happening A, it's simply the total number of A events over the total number of what? Events. For instance, if you have a basket which has 7 bananas and 3 apples. So what's the probability of picking an apple? It is 3 out of the total number of fruits. How many fruits do we have in total? Yeah, 10. So 0.3. That's how we find A. How do we find B? The number of elements that are bananas, 3, 7 out of the total number of fruits, which is 10. Then we also learned how to come up with a complement. Complement is what is not. So to find what is not is simply 1 minus the actual probability. So if 30% are apples, what's the probability that it's not an apple? Is 1 minus 30%, or 1 minus 0.3. So the fruits that are not apples, they should be 70%. In short, if A is 10%, the complement of A is 90%. If A is 0.4, the complement of A is 0.6. Are we together? Then
Yeah.
we have a union set. This is the most faithful formula, which simply asserts that the probability of A plus the probability of B, we subtract the intersection. That is how we get the union set. To intersect is to find a common ground. So where A and B are crossing each other, we call that the intersection. So the intersection of A and B is this middle. That is what we call A and B. But if you are taking 3 courses and are sharing QM. So to unite the courses you're getting, it's 3 plus 3 minus the course you're sharing 1. So it's 5, not 6 courses. That's what it means, this column. So you remove the common ground. Okay. Then we also go to conditional probability. A given B is simply probability of A intersection B over the probability of B. You bring back the common, the ground later, the base. If we're dealing with B given A, what we do, we bring the A down here. Then on top, we intersect the 2 letters, the only 2 letters here, A and B. Of course, we usually like to start with the letter that comes facing the alphabet, but there's no harm if you started with B intersection A. So the key thing is this guy goes down there. This guy goes down there. So this is what we call conditional probability. Then we also have what we call theorem 2, which simply says if you have A here, just add the 2 intersections, A intersection B and A intersection B. But the common letter which is there, if A is subject to a formula, you put the intersection on the other letter. So the intersection won't be on A, complement will be on the other letter B. I repeat, if you are being asked to find the probability of B using theorem 2, just intersect these 2 letters, A and B, A and B. So since B is subject of formula, the complement will be on the other letter. What other letter do we have? If this is B, the other letter is A. In short, you pick the common letter here. Which letter is the same? A is the same. So that will be the subject. Which letter is the same here? B is the same. So which is the subject there? So if we have A intersection D plus B intersection D plus C intersection D, you pick the common letter which is prevailing. And which letter is that? Common letter prevailing is letter D. So this is what we call theorem 2. So if you don't know, you don't know, you cannot guess. The other conditions you need to know is mutual exclusiveness. To be mutually exclusive is to have nothing in common. If your intersection is 0, it means they are mutually exclusive. So A and B are mutually exclusive. So mutually exclusive events are disjoint events. Somebody says you and I are mutually exclusive. It means you and I have nothing in common. The intersection is an empty set. Other condition that you need to have in mind is independence. If A and B are deemed to be independent, A given B must be equal to A, meaning this guy doesn't determine the existence of the numerator. So A given B still remains A. The existence of A is not affected by the denominator. In like manner, if we have B given A, for this to be independent, B given A must still remain to be what? B. So this is the rule of independence. These are just rules. You need to remember them. Can use other letters if you want. Y given X. How do we know they're independent? If the probability of Y given X still remains Y. Or if the probability of X given Y still remains X. Are we following?
Yes.
Okay. So these are the key axioms of probability that if you did not know, you cannot guess. And now a question will come as follows. Suppose the probability of A is 0.2. probability of B is 0.3, and probability of A given B is 0.2. Then you're being asked to find the intersection of A and B, the union of A and B, the complement of A, the complement on A but B, the complement of B but A, the probability of B given A, probability of A given B, to know whether they're mutually exclusive, to know whether they're independent. So we're going to use what we've just learned to deduce these key important axioms. To start with, whenever you see something slash, just use the rule which we call Bayes' theorem to expand it. That is conditional probability. So let's expand A given B. How do we expand this? It will be probability of what? A intersection B, because these are the only two letters that we have. And this guy who's down there, we bring him down there. So probability of B. At least this, you get your mark for the method. Then we substitute. Where there's A given B, we have 0.2. So we now put our 0.2 here. Equals the intersection, we don't know. But we know we've been given the probability of B. Our probability of B is 0.4. So we cross multiply this by that, 1 times that. So here we have the intersection, A intersection B, because when we multiply by 1, it still remains A intersection B. Then 0.2, we multiply it to 0.4, we get 0.08. So this is how we find the intersection. So now the second part is a union set. A union set is the most faithful formula. Who remembers the formula for union set? Simply probability of A plus the probability of B minus the intersection A intersection B. So our A 0.2, our B 0.4. Intersection, we're just from calculating. So if you get the intersection wrong, it simply means that you are getting our union set wrong. So when you add 0.2 plus 0.4 is 0.6 minus 0.08, we get 0.52. So we're using what has been given: A 0.2, B 0.4. Then the intersection is just what we calculated there. Are we following? Are we together?
Yes, sir.
Complement is what you don't have. So A is 0.2, meaning the complement should be 1 minus 0.2. So meaning complement of A should simply be 1 minus 0.2, which is the probability of A. So 1 minus 0.2 will give you 0.8. Okay. So if I may ask, although it hasn't been asked, what therefore becomes the complement of B? If our B is 0.4, what is the complement of B?
1 minus 0.4.
Excellent, which is 0.6. Correct. Now we go to this notation. Now this notation has a complement in the intersection. Already this clearly tells you that this is theorem 2. If the cassette is on A, meaning the subjective formula must be on B. If here the cassette is on B, the subjective formula must be on A. So theorem 2, there are only two things, like I said. This one here, if A is subject, meaning the cassette is on B. If B is subject, the cassette is what? On A. So to understand this one here, you just need to know in your mind that you're going to make B subject. So probability of B is going to be probability of what? A intersection B plus A intersection B. So in this case, the A here made to be on A, which we are looking for. So now let's substitute. What is the probability of B? 0.4. What is the probability of A complement on B? We don't know. But what is the
Sorry,
intersection? Yes, this.
I'm not sure if I'm the one who's missed it. I thought the cassette or the line on top is supposed to be on the common number. Or is it because we are given already the B, A complement and B? So it should be on B automatically. I don't know.
Yes, you need to navigate around this formula here. So sometimes
Mhm.
they'll not ask you to find A because A has been given. They're asking you to find the complement on B. So this is what we're looking for. So in your mind, just know that if the complement, the cassette is on B, meaning A
We are
also
looking for A.
not necessarily looking for
Okay.
A. We need to write the theorem 2 with A being the subject of the formula, because it's simply the common letter here is what? A. So it's A is A. So you just write the whole formula and substitute what you are given. When the
Okay.
cassette is on A here, just know that write it to say B should be outside. So there's B there, A intersection B on the A, and this one leave it as it is. So in this case, the reason why we are interested in knowing where the cassette is, it will help us just straight away go to the formula. If the cassette is on the A, then don't think twice, just know that the subject formula is B. So just write it here to say B, A intersection B. So since there's B there, the cassette is on A to start with. Then we already given the probability of B is 0.4. Here, we don't know what this is. But here we calculated intersection of A and B as 0.08. So when this one goes this side, 0.4 minus 0.08. So we're going to have what? A cassette intersection B. So when we subtract that, it gets 0.32. The other question now is asking, what is the probability of A intersection B? The cassette is now on the B. So just simply go to say, oh, since the cassette they're asking for is on B, meaning the subject here in this case must be what? A.
A.
Yes, so it's just simply go say probability of A. You simply know that it's what? A intersection B plus A intersection B. But in this case, since A is subject to formula, the cassette should be on the what? On the B, which we are looking for here. So A is 0.2. You substitute now 0.2. Cassette on B, we don't know. That's what we want to solve. Intersection, normal, we calculated it as 0.08. So how do we find the complement on B? We simply subtract 0.2 minus 0.08. So this will give us what? A intersection B. Cassette there. So this will be 0.08. 1, 2. Are there any questions at this point? Any questions at this point? Are we together?
Yes.
All right, please ask if you're behind.
I think it's clear, no?
Okay, so now we proceed to the other questions that were being asked. So we're done with 1, 2, 3, 4, 5. So they're asking us B given A. So B given A. Now we know that A given B is simply A intersection B over that over B. But suppose they swap everything there. They say, let us find B given A. Who can help us expand? How do we expand B given A? B given A. The safest is you start with the denominator. Take this down. A, push it down there. Then on top, intersect the two letters starting with the letter which comes first in the alphabet. Then we already found our A intersection B as 0.08. And here, the probability of A is 0.2. So when we divide that, we get 0.4. So that is how we find our B given A. How about our A given B? Already is given there. It's just for the sake of you learning the principle. A given B. So A given B, who can expand for us? How do we expand A given B?
So we'll get our denominator first. So probability open brackets B at the bottom.
Correct.
And then on top, we're going to say probability open brackets. Then we are following the alphabet. So we'll say A, is it intersection B? Across the brackets.
Then what was our A intersection B? We already calculated it at 0.08. And our B, 0.4. So when you divide 0.4 into 0.08, you get 0.2, which tallies with what we have here. Okay. Then we go to the conditions. Are the events A and B mutually exclusive? Who remembers the condition for mutually exclusive? We can only agree that A and B are mutually exclusive on what condition? If they have nothing in common. If only if their intersection is equal to what? 0. That is when we can agree that they are mutually exclusive. If and only if they are equal to 0. But in this case, our intersection was 0.08, which is not equal to 0. So we can say they are not mutually exclusive. Here you're just comparing the figures. There are 3 steps we need to follow. Number 1, you state the condition, which we have done there. Number 2, you do what? Compare the figures. Is 0 equal to 0.8? No. And number 3, conclude. If they were same, 0 is equal to 0, we say they're mutually exclusive. Let's try to do the same for the second part, independence. What is the condition for independence? We say A given B must be equal to what? A. I say the independence should be the bottom guy must not affect the top guy. I usually give an example of a doctor, lady who's married to any man. They always maintain their maiden name. So, Madam Chipo Banda, Dr. Chipo Banda, whether it's married to a Njovu or a Piri, should be Dr. Banda. So, Chipo Banda given Piri, she's still Chipo Banda. So she still remains her maiden name. So independencies, you're not affected by the bottom guy. So state the condition. Number one. Number two, compare the figures. What is our A given B? 0.2. And what was our A? It was also 0.2. Are they the same? Yes. So what is our conclusion? Yes, they are independent. A and B are independent. So this is how you get your marks, by understanding these axioms. And these axioms are very important everywhere because they guide you at every stage. So I will quickly take you through a question to do with this principle. Then I'll leave you with homework, which I require of you. Then yeah. Are there any questions before I proceed? Are there any questions? Before I proceed? Is it clear? Okay, so
Yes,
let's go to our revision kit here. So we are told, let me beam it so that you're able to clearly see it. Okay, so I need us to think through intelligently what we've just been learning. Okay, so we are told that an insurer has two types of policies: home insurance and car insurance. So 70% have a home insurance, so you can start tabulating the information. So we can say H to be probability of H. So 70% have what? Home insurance. So probability of H is 0.7. We put it there systematically. And we also told 80% have a car insurance. So probability of car is 80%, so 0.8. Then we're also told that every customer has at least one of the two. So meaning home union car is equal to 1. So meaning at least one of them. So 100% of the population has what? An insurance. Now help me find the probability that a person does not have a car insurance. What are they asking for? A person does not have a car insurance. The complement. To not have is what? Complement. The complement of C. So what is the complement of C?
1 minus 0.8.
1 minus the probability of C, which is 0.8. Correct. So which is what? 0.2. Are we together? Then a person has a car insurance and the word "and" means intersection. The word "or" means what? Union. All right. So we know from our axiom that the probability of what? A union B. Who remembers the formula for A union B? Probability of A plus what? Probability of B.
B minus the intersection.
Good, minus intersection. A and B. So to make this subject a formula, you can say A intersection B is therefore equal to what? Probability of what? A plus probability of what? B minus what? The union set of A union B. Okay. So if we're going to actualize this, and the probability of what? Car insurance intersection home insurance is equal to what? Probability of car plus probability of home minus probability of what? Car union home. So car was 0.8, home was 0.7, the union set was 1. So 0.8 plus 0.7 get 1.5, isn't it? So 1.5 minus 1 is 0.5. So this is how we find has a car and home insurance. How about has a home insurance given he has a car? So probability home given car. So this would be probability of what? H intersection C, or since we're starting the letter which comes first in the alphabet, C intersection H. Then we bring this one down there, probability of C. So here, the intersection, we just calculated it now, 0.5. And the probability of C is 0.8. You can compute on your own. How about does not have a car insurance given he has a home? So does not have a car insurance is car complement given home. So this will give you intersect the two letters, except one letter has a casote. Then down there, we put what? Probability of H. Then since we know that the casote is on A, or on C in this case, so you rewrite this and solve for this formula. So if the casote is on C, I told you using your mind game, your mind, so meaning the subject formula should have been what? The other letter, H. So just put the two letters C intersection H plus C intersection H. And the complement, since subject is H, is on C. So you fill in the blanks and solve for this complement, which you put here when you solve it. H, you already found it as 0.7. And that is how you're going to find your answer. I'm not going to spoon feed you, that will be a homework. So I expect you to take your time to really visit this. It is a handful, I know, but I now want you to think. This is the toughest topic, which requires dedication.
Sorry, on this one, yeah, it does require thinking, honestly. The last one where we brought in the casote, the principles on the other one, I think I was following it. Is it because one is not there, does not have a car
Yes,
insurance, so we
yes, yeah. Does not have given means you put a slash there. So does not have car insurance. So car insurance, you put a casote.
okay, all right, I've understood. Thank you.
All right. So any other questions? All right, I'll end here. I'll share this video. Specifically, you can share with your friends and colleagues. as well as those ones that are not in our class. Send your solutions to my number. People want to start joining when the school becomes staff, so we don't want that headache. So if you have any friends that are still lagging in this course, you can share them this video as well, so that they could be with us. I will send you the revision kits already on the group, so just check on this revision kit on page 5, question number 9. Right, I'll send it separately as well.